In this activity, we're going to be learning about Apple Avalanche. We're going to be constructing a code that is basically going to be a typing game. So far, we've created games that we ended up having catch a turtle, right, where we use user input by clicking on the turtle. We also ended up setting up where it's able to keep track of the score and then also create a custom leaderboard for this, right? Our next step into our game creating journey, our game creating adventure, is where we can end up using user input that is basically us clicking on the keyboard certain keys. So what you're going to end up having by the end of this is going to be code that looks something like this. All right, so let's go ahead and let's get down to business. First off, in terms of our goals, we're going to create a game where the user can control game behavior from the keyboard. We're also going to continue learning more about manipulating lists, and then we're going to ensure that we're applying our best practices in commenting our code. All right, guys, what I really want to be putting the focus on for this is really making sure that we're looking at the instructions and breaking down all the instructions. In terms of this, I also want to preface this though. In terms of the instructions that they end up giving us or the guidance that they give us, this is not too guided, and so that's really my hope in creating this video, is that I can kind of guide you a little bit more, because the actual code that they provide us or those instructions, it is a bit more minimal, but it's still important that we're paying attention to those instructions. So we talked about how we've been adding images in, right? We ended up using the run robot run code, and we had that where there were the robot images, right, that you had to end up navigating through that maze. So we've done that before, but in this game, we're going to end up using custom images as well, where it's going to be an apple. We're going to also have a pear in there, and then there's also going to be a background image. What we're going to go ahead and start off by doing is downloading this code that's in step number 1. Now, please do ensure that you do end up extracting that. So I had the zip file, I ended up extracting it, and what I'm going to do now is I ended up creating this folder. Now the folder is activity 123, so make sure that you do create a new folder called 123. Then you can go ahead and open this. Now in the file explorer, what we can do is we can drop the contents that we just downloaded, and remember, we want to be dropping it in here because we want to end up having all of these in that folder that is currently open, so that we can reference these using the relative directories. Now remember, if you end up running into some issues, instead of copying the relative path, you could end up copying the actual absolute path. However, if you give your code to anybody else, or if you turn it into me and I try to run your code, obviously it's not going to work for me, because the directory of where those files exist, it's not going to be the same on my computer as it is on your computer. But anyways, let's go ahead, let's look at our contents that we've got here. So we've got a main Python file. Let's go ahead and let's scroll down here. So we're using the Apple image, so that's gonna be that GIF image that's referenced over here. We're gonna look at that in a second. We create the window, we have the actual setup for this. We also add in our Apple image as a shape, right? We had to do that with the run robot run code. We create the instance of the apple, and then we've got these functions, right? So it's draw apple, and then we got the function call. Remember, the function call must always occur after we've created that function. Then we got the main loop function here too. Now in terms of the contents that we've got here for those images, we got the apple GIF image. We've also got this background image we're going to use, and we also have this pear image as well. All right, so let's go ahead, let's get back to the etext, and let's see what all we've got here. So we extracted those files. They say that we're going to change this as apple_1. So remember, we always want to follow this step by step very carefully. So we're going to do apple_1.py. Perfect. We're going to save this. Now it is also very important that you're consistently backing up your code with this. One of the things they end up mentioning here is how we can end up running this code just from the terminal. So if you go to the VS Code terminal, you can go up here, new terminal, and what we can actually do every time that you run your Python files, as you can see I'm running that, it's actually just calling that Python file. And so if we go back in here, I can bring up that new terminal again. Now for me on the MacBook, I have to specify Python 3. If you're on the Windows computer, just type in Python, right, and then you can type in your name. But for me, I have to do Python 3. Then we go apple_1.py. Remember, this is if you're on Mac that you do that. And so if I end up doing this, you'll see that it runs our actual code here, right? So remember, if you are on the Windows, for Windows, you have to end up putting in here Python and then apple_1.py. Okay? So anyways, that's our code that we've got so far. Basically, that apple is just being drawn out right here. Now, this is another line of code that we have not really seen yet, wn.update. Okay, so we'll check that out. We'll see what that's all about. So they also have observe the source code, so it defines a function called draw apple that takes the active apple as a parameter. at runtime, what kind of object is active apple? So they have this little check for understanding question here. So at runtime, active apple, that's what's passed into this function, right? So this is the parameter. Remember, anytime that we call a function, what we pass into that function is the argument. The argument ends up becoming the parameter. So apples, what we're passing in there, that's going to end up becoming active apple. So at runtime, once we end up running this, apple is actually just a turtle instance, right? So let's go ahead, let's go back in here. So select the correct type of active apple at runtime. So that's just a turtle instance there. All right. Let's go ahead and move on. They want us to modify our code so that we use the pair image instead. And so just as we saw over here, it's pair.gif, right? So we could end up providing that change, and then we can end up running this. If I run this, you'll see our apple now becomes a pair. So kind of cool. And then let's go ahead and continue. For our typing game, you will need a static tree image as the background. You will need apple images, so apple images, plural there, to fall from the tree. When you want to embed a stationary image as the background of your screen, the code is a little simpler, right? So we do want that. It's going to simplify our lives a whole lot more. So what we could do is we could take this line of code right here, the wn.bg pick, and then what we're going to do is after we create that, after we have the setup, I'm going to put it right here, and that's going to be the background GIF. And so now if we run this code, you'll end up seeing that we got the pair in the front, and then we've also got this background. So that's looking pretty good. So what they have us do here now is modify your code by defining and calling a function that causes the apple to fall or move to the ground. The following functions may be helpful in terms of finding out where the turtle starts and determining how far it is to the ground. So we got X core and good old Y core. In terms of this, you could end up looking at the need help section here, right? So pause that, you can read that. But what we're gonna end up doing is the following. What I'm thinking is, let's bring back up this turtle image. At this point, for instance, we're gonna have random apples, or in this case right now it's a pair. I'm gonna switch it to apple very shortly. But what we're gonna do is we're gonna have this active apple, right? That's gonna end up dropping. Now, these are gonna be set at random points, right, for X and Y. Now, what needs to happen every time they drop? Well, it's gonna be the case where they're gonna be accelerated in the Y axis, right? They're not actually gonna be accelerated in the X axis at all. It's just gonna be entirely Y axis movement. And so what I'm gonna do is I'm gonna actually just have this move at a constant velocity down, right? So we're gonna say go to, and the only thing I'm gonna be changing is gonna be the Y-axis value. So what I'm gonna do here in my setup is I'm gonna establish the ground, and I'm gonna say that that's gonna be a solid negative 150 pixels. So we got the draw apple. Now what I'm gonna do is I'm gonna define drop apple. I'm gonna pass in there the active apple, and then what we can do here is I can store temporarily our X value. Now the X, I'm gonna go active apple dot XPOS, right? Then what I can end up doing is I can tell that active apple, hey, I want you to go to X, comma, and then I want you to go to that ground value. Now in terms of this, if we ended up running this code, right? So I have this as apple being passed in here. Let's run this, let's see what happens. I'm referencing ground here. Now as you can see, we have active apple that has no, okay, so yeah, POS, yikers. So let's do that. POS, and then we could reference that 0th index. Let's see what that does. Nice. So now, just because POS, remember, returns two items, it's going to be the X and Y coordinate. So we just want that first element, which is the 0th index. So we're going to end up getting that guy. So that's going to be the X, and then we're going to go to the ground. Now let's run that one more time. Let's make sure that we like that. So it's going to go to the ground. Let's see here. Does that seem pretty solid? What if we try, let's try it negative 160. Let's see what that looks like. Nice. I think I like that better, negative 160. So we're going to go ahead and roll with that. Choose something that works for you, though. Probably anywhere from negative 150 to negative 160 will be good. And so now, ground there. We've got that. So remember, we might run into the case, though, where ground ends up giving us an issue. Maybe we can't access it in that variable. What you would want to do here is declare global variables. So anytime that we're using variables that are not passed into the function or are created or used in a function, we always want to make those global. So we can go global. We're going to make ground global, and we'll probably end up seeing some other things are going to need to be global as well if we run into any of those issues. But anyways, I now have it where it'll draw the apple, and then we're going to drop that same apple that's created there. Okay. So now, they had the need help section. You could have checked that out. Because the apple is a turtle, by default, it draws a line whenever it moves. If you have not already, modify your code so that the apple does not draw the line. So all we've got to do here is, before we end up moving that apple, right, we want to go active apple dot pin up, okay? Now, what we could also end up doing is you could also pop this out here, right, after you immediately create that apple. So it could be apple.pu there. Now, if it's the case here, we probably won't end up needing that, right? Let's run our code. Let's see what happens. So in terms of it making lines, it did not. So now we're good. Okay, very good. So we ended up setting that up. We're blowing through this. Let's go ahead. Let's continue. So section 2, key presses here. This is section 2 of 6, key presses. So for our typing game to work, the apples will fall from the tree whenever the user types the letter that's displayed, and that letter is going to appear on the user, right? Or not on the user, but on that apple. And so what we need to do is we need to come up with a way with that our program will be able to detect the keys that the user is pressing, right? So this is vital to providing additional interactivity between the user and the program, right? It's going to make our games more fun if we can end up interacting with the keyboard. So let's explore this and add this functionality to the typing game. So they have this code right here below. What it's going to do is it's going to end up defining a function that's going to draw out A. And then we've got this function right here, which is called onKeyPress. Now what this does, this first item that's in here, this first argument, is the function that we're going to call. And that first function is going to be called whenever this key that we have in quotations here is pressed, okay? So we also have the wn.listen. That is very, very important as well. We need that so that our program can basically listen to the keyboard input, okay? So what we could do is we can now take this function. We also have drawer here, so I'm going to just copy this new code that we have here, right? And I'm going to take that, and then I'm going to paste it in here. So we're going to go, let's go like right here. And then I'm going to move some of this stuff around. So this function, we're going to move down here so that it's in our functions, right? So we're going to have function right there. And then we also need that call. And so I'm going to put that function call down here. This also is explaining that call. So we're going to take that guy too, and we're going to put that right here. Okay, so this call to the onKeyPress is going to set it so that draw in A as the function that will be called when the A key is pressed, okay? So let's go ahead and let's run this. We also have drawer being created. Now, where are we using drawer? We're gonna be using drawer. We're at draw on A, drawer.color. Okay, so let's run this code. Let's see if everything works. Now we have that where it dropped. Now if I press A, boom, A is gonna show up in there. So now we're seeing how this onKeyPress is working. Now, however, whenever we press A, do we want the letter to show up? Then no, we don't want that to happen, right? We want the apple to drop whenever that happens. So you've seen that. Now they talk about here some additional information. So it takes a function as its argument, and then also string representation as the key that we're going to end up having pressed whenever we call that function. So it's important to know that. There's also the listen method. That's going to ensure that our program is going to listen to the keyboard to see what is pressed, okay? So what they want us to do now in step 10 here, step 10 is saying modify your program to make your apple drop when the user presses the A key, all right? So let's go ahead, let's pop in here. So draw in A. What we want to do is we want to go ahead and call the drop apple function, right? So drop apple. So we could do that, and then we'll also have it where it's going to create the A still, right? So let's go ahead, let's go in here, A. Ooh, so I'm running into some issues. Let's see here. What are we running into? Drop apple, missing one positional argument, active apple. Okay, nice. So how can we solve that issue? Well, we can make active apple be either established outside of here, or we can end up making that a global variable, right? So let's go ahead and let's see what happens if we put active apple as a global variable. So it's going to draw apple global active apple. Now it's given us an issue here. Let's see what happens. Active apple is parameter and global. So if that's the case, we want to take that guy out. So what we can also do here, okay, so let's say that active apple is going to be global. Well, you take this out of here. Let's see here. So if we're dropping the apple, we now want it to be the case. So if we draw in A, yeah, I'm going to say this. We're going to make the active apple temporarily. We're going to make that a global global variable. So we're going to do global in here, active underscore apple. So we've got that in there, right? So we established that. Now what I'm going to say here is the apple underneath this, active underscore apple, is going to be equal to apple, okay? So now if we run this code, we're going to see that this should work out. We ran into an issue again. Let's hear, draw apple takes 0 positional arguments, but 1 was given. So in terms of this, whenever we're calling this, we want to take these two guys out. We don't need those anymore, right? Except for we do need draw apple. So let's call draw apple, because we do want that apple to be drawn. So let's go ahead and call this. So we drew the apple. Now whenever we press A, as you can see, it's dropped, and then that letter shows up. Okay? Now, bingo, we got it. So modify your program to make the apple drop when the user presses the A key. Perfect. We've done that so far. So now they have choose one of the following. You can either do the harder method, or you can do the easier method. Guess which one we're going to do? That is exactly right, the harder method. So we're going to do the harder way about this. What they want us to do is add function to our code that draws a white letter A over the middle of your apple, right? And this should be before it drops. So we were shown in the past, it ended up happening after it dropped, that A showed up. It's before it drops. Whenever that apple is displayed, it should have the letter on there. It's going to indicate that user is supposed to type the letter A. You may want to reference the code above to see how the right function works. So we've used that before though. So we should feel pretty confident using that. We're going to call that function from your apple drawing function. Okay. And once you've gotten the letter to draw, you may notice that it doesn't draw right in the middle of the apple. So what we're going to have to do is we're going to have to experiment a bit here. They end up saying if you set the size of the letter font at 55, you can use 18 as the X offset and 40 as the Y offset. But don't forget to modify that by the X and Y coordinates. Perfect. We'll end up using that. Now they do end up telling us important in step 13, you will learn how to remove the letter in apple from the screen. Do not worry about moving the letter with the apple as it drops. So they say don't worry about that just yet. So step 12 here, you may have noticed your apple bouncing around as you drew the letter A. To prevent this from happening, you can turn off the tracing of your turtle's path as shown below. So the tracer method, as well as the update method in our code, is going to allow us to ensure that either the turtle's path is being traced at certain times or that the turtle's path is not going to be traced, and it's going to happen almost instantly. So they kind of have this code set up here, and now if you look at this, we'll run this again, kind of take a look at this. It seems to me this happens almost instantly here, and then this one's slower, right? What we can also do is we could change the speed of each of these turtles, but whenever we uncomment this, you'll see that there's no third turtle that's actually drawn, right? We have 3 drawers, and whenever I uncomment the update, you'll see that finally then our third turtle actually ends up drawing. And so what we can see is that once we use true, tracer true, and then if we go to tracer false again, then it's going to be the case that we're going to have to use wn.update. All right, so reflect on that, add that into your engineering notebook. You can also look at this for help with tracer. You could read that. We're going to go ahead and continue on to step 13 though. You don't want fallen apples and random letters being left on the screen once the user makes the apple fall. So they have us using the following methods to remove the fallen apple and the letter that the user typed. So we have .clear, right? We also have the hide turtle function and then show turtle function, okay? So that's going to be important for step 13. Now let's see here. In step 13, you will learn how to remove it. Do not worry about moving the letter with the apple as it drops. Okay, so they just want us to have it where it can clear. So let's try to do that. Let's try to set up our code here so that this A is going to also show up whenever we draw that apple. Okay, so let's try doing that. So instead of having draw an A be at the beginning here and then having it be where that's whenever it drops the apple, instead of that, I'm going to have drop the apple being called on here, right? So drop the apple. Now we want to take out those parentheses there. So that's whenever we press A. Now whenever we go to draw that apple though, remember we're calling that function first. Whenever we go to draw that apple, what I want to do is I want to get that letter, right? And so let's say that we have letter equal to A here, okay? What I want to do is I want to draw an A, right? So actually we probably don't even need to do this. We're just going to call the function draw an A. I was kind of thinking ahead of this, how we can get our code set up for that, but let's just call this draw an A. Let's look at this. Now as you can see, we run into that issue, right, where the A is not centered here. So let's see, they have the dot right function. If we have 55 for the font, then what we can do is this. If I find x comma y, we can find that from our active apple dot pos, right? Then what we can do is we can tell our drawer to hide the turtle. Don't know if we've done that yet. Let's make sure. So drawer. So we have not. Let's actually do that here. Drawer dot hide turtle. That way we don't have to put it out here. It's just going to stay hidden. Then what I want to do is go to, and then we can end up telling it these x and y positions. Now, as they said in the e-text, right, they tell us this. They're giving us some free information here, and it is, if we have the font as 55, we can use the x offset as 18. So what that's telling me is that we got to go over to the left 18, which if you guys are watching that, it's this way. It's left because it's mirrored on my camera. And then we've got to go, what, up or down 40. So I'm just basing this off of what we just saw here. So let's test this out. So once again, the run through. How's our code going to end up running? First, we're going to end up creating all these. We're going to import the turtle. We're going to declare our global variables. We're going to set up these initial setup items, right? We're going to establish these turtle instances. We've defined these functions. We're going to end up calling just the draw apple function at first, right? Now, if we go to the draw apple, it's going to set active apple as a global variable, right? It's going to ensure that we know that. Then it's going to call the function draw in a. That's going to draw the a for us, right? Now, in terms of the active apple, we're going to set the shape to be an apple image, and then we're going to update this, okay? Now, what we might end up seeing is that our letter might be kind of lost. So as you can see, the letter's lost. Now, this is what I was thinking too while we were doing this. Why is that the case? We draw the letter first and then we create the apple. What we need to do is we need to have the apple on there and then we need to draw the A. So let's try that again. Perfect. Now, as you can see, that is centered. Now, one other thing that I want to mention, it did talk about how this needs to be white text. So we're going to switch this to white for our drawer color. And so now let's try this again. Let's make sure everything's good. Perfect. Now, whenever we hit A, it's calling the drop apple function. Now, what is not happening? The apple did drop, right? That's good. However, the pair as well as the letter is still showing up, right? So what we got to do is we got to clear those. So for the drop apple function, what we want to do is we want to set this up so that the active apple is going to be hidden, right? Now, whenever we draw that apple, though, we want to ensure that it is shown again. So let's ensure that state, right? Because we're going to be creating many of these apples. So we're going to show the turtle. And then what we also want to end up doing is, after we draw that turtle, so we're going to have the position, we're going to tell the drawer to go to a certain spot. No, sorry, this is it, the drop function. What I want to do is I want to go drawer dot clear, right? Because it's going to clear out that previous entry, right? So let's try this out. A, boom, it dropped, A cleared, we're all good to go. Looks like our code's pretty solid so far. Let's do this real quick. We're gonna end up zooming out of this. Hopefully this will be a little helpful for y'all too. Some people were kind of telling me in my last video that everything was too zoomed in, so I'm gonna zoom out, but you can just kind of see where we're at with the code, okay? So now what we're gonna be doing is we're gonna be heading on to section 3, and this is going to be step 14. So adding randomness. Randomness is going to make our game a bit more fun. So to this point, you have been making small changes to the Apple Avalanche typing game code. For the rest of the activity, you will work on larger portions on your own. So that's exactly what I'm talking about, guys. They're trusting in you to be able to complete these instructions. It's going to be a bit of a challenge, right? But you got me here. I'm going to be walking you through this in case you have any difficulties on any section. So this will require you to plan in advance and iterate on your design if it does not work the first time. You're going to run into lots of errors, right? We've learned about debugging errors, though, so trust yourselves. Be looking at where the errors are occurring. Think about this all as the events that are occurring, right? Everything is sequential. Go step by step. Try to find out what that order is. Now, in terms of the reminder, program incrementally and test often. So after we make a change, we want to end up testing that to see if that change worked. If that change does not work, we got to go back. We got to solve out where that issue is happening, right? Print also is our best friend. So in the previous activity, you have seen and used randint, right? So that was whenever we needed to generate random numbers within a certain range. So if the apple, or after the apple falls from the tree, what we want to do is we want to reposition it somewhere random, and then we also want to give it a random letter. So this is going to be using randint to find that random range in the x-axis and the y-axis, and then also random.choice. So it's the .choice function within the random module. that's going to end up choosing one of these letters at random for us to use, right? So to help you keep your thoughts organized, the two to-do commented program outlines have been included below. The first one is going to outline a program that correlates apples to letters. The second one is going to outline a program that does not. So the second one is if you're going that easy route, we're going the hard route, right? So we're going to do this first one. So we do already have completed parts of our code too. Look at this. It says note. We already have completed parts. We're not going to be starting from a blank file, right? All this is this is just for us to bring in to help us organize our code, okay? So we already have this. We're going to take this code and we're going to end up pasting it into here, okay? So in terms of the functions, what we're going to do is we're going to replace it with this to-do. Now, as you can see, there are many to-dos in here, right? What we're going to do is we're going to go through those. There's going to be some of this code down here. So this is old previous code, right? And we're going to end up taking this. There's probably going to be parts of this that we're going to have to pop up here. One of the other things I'm noticing, we're running into this error. I'm going to put this, fix this, so that we know that we need to come back to that, okay? So try not to freak out. This is basically set up so that we have the instructions on what all we need to do, right? These are the instructions we want to follow. This is the previous code we already have written. What I also want to end up doing is I want to take the time to back up our code too. So we're on step 14. What I'm going to do is I'm going to press Control-Shift-S. What I'm going to do as well in 1, 2, 3, I'm going to create a new folder. I'm going to call that Code Backups. Code Backups. And so what we can do here is we can save this, and this is to step 13. So Apple 1, step 13.py. Now what I want to do is I want to go back in. I'm going to do File, Open Folder. We're going to make sure that we're still in the 1, 2, 3 folder. Now what I'm going to do is I'm just going to bring up my previous version, right? I'm not even going to mess with the code backups. We're just having those in case of we end up making some big errors. We need to go back to a previous version. Perfect, we got it. So that's up until the point of step 13. So let's go ahead, let's check this out. So in each of the programs outlined above, you have been provided with an example of how to use the range function. So read the description in the code and search the internet to gather enough information to write your own description of how the range function works. So go ahead and do that. We've kind of talked about the range function though, right? If we put down range 10, it's going to give us the values from 0 all the way up to that number, not including that last number. However, if we switch it up, we go range 2, 5. You might be thinking it's not going to include this first number, and then it's not going to include this last one either. Guess what? It will be inclusive of this first number. So range 2, 5 is going to give us 2, 3, and 4. So it just doesn't include that last number always. Okay? So in terms of the for and while loop, there are benefits for using the for loop. In this case, in particular, the for loop is a whole lot better because it basically is going to save us 2 lines of code. If we're using a for loop to iterate and generate indexes, right? So let's say that we're trying to get I, we're trying to iterate through I so that it goes 0 all the way to 9. In the case where if we use this code here with the for loop, only 1 line of code. If you use the while loop, well, not only do you have to establish I, you have to set up the condition while I is less than 10, and then within that code you also have to iterate I or increment I, right? So while loops end up wasting a whole lot of time, right? So we use the for loop. Anyways, so they want us to build the code necessary to create a list of all the letters from the home row of the keyboard, or they say the entire alphabet if you're feeling ambitious, and use the pop function. So in combination with randint to retrieve random letters from that list as needed. Make sure you comb through your code and update anything necessary to draw the random letter instead of just the letter A. Guys, what they're saying here is that you've got to create an entire list of the entries for the alphabet. Guess what? Is there a way to do that more efficiently than just literally writing out those? Yes. What we're going to do is we're going to use a module. It's going to be kind of your best friend on this. What we can do is we can import string. That's what that's called. Now with string, what I can do here is I can establish a letters list. So letters equals list. We can go string dot. Now if you look at this, we can do dot lowercase. That's going to end up getting us all of the alphabetical, or all of the letters in the alphabet in lowercase, and it's going to create it as a list. So check this out. If I print letters now, what this is going to do, and by the way, this is a built-in module too, so we don't have to use like pip install, or if you're in the Mac, pip3 install, you don't have to use that. It's built-in function, built-in module, so we don't need it. If I exit out of this, do you guys see? We have all the letters in the alphabet there. Perfect. So that just saved us a whole lot of time. We're also going to be using this later on in this activity to save us some time too. So they say build the code necessary to create a list of all the letters from the home row, okay, or the entire alphabet, and use the pop function in combination with randint to retrieve random letters from that list as needed. So let's do this, you guys. Let's do this. Let's go back in here. And what I'm going to do is I'm going to use that letters. Now I'm going to establish this as a global value. So letters here. And then what we're going to do is we're going to go back into our previous code. Now, do you see how there's the active apple show turtle, active apple.shape, and then there's draw in A? So let's do this. Let's change this to draw letter. We're going to change this to draw letter. And then what we're going to do is we're going to generate this actual letter, right? So letter equals, and then I'm going to do r.choice. Now, we're going to pass letters in there. Now, why are we running into this issue right here up at the top? Import random as r, right? So now let's go back down into here. Letter equals r.choice, that letter. Then what I want to do is instead of this, I want to put the letter on here, right? Now what I also want to do is if we're using this letter once, we're going to remove it, right? I want to get it so that that letter is removed from our potential letters list. So let's go letters, and then let's put dot. What was that? Was that delete? Letters dot remove, and then let's see here. So the value is the string, so it's going to remove that first occurrence of the value. So what we're going to pop in here now is letter. This is going to remove the letter that was just displayed on the turtle, right, from our list. And so now if we end up doing this, like we can print letters, and what we're going to see is every time we get this apple to drop, it's going to end up taking that value out of that letter that we just used out of our alphabetical list. So let's make sure that we don't have anywhere else in here that says draw A. So let's do Control F. Let's do draw, and then what do we have in A? In A. So that was that old function. Perfect. Okay. So it should be good. Let's test this out now. So we have V showing up. Nice. So we got this randomness. Let's try to bring this over here so that we can see the alphabet. So now as you can see there's V in there. Now since we assigned V, it took it out, right? It goes U, W. So now if I press A, now we've got it. Okay, well we're not calling that function again, right? So what needs to happen after we drop the apple, we're gonna be running into some things, right? So it's gonna go to a new position whenever we draw the apple, okay? So let's see here, let's go back into this. Let's make sure we're not getting too ahead of ourselves. Create a list of all the letters and use the pop function in combination with randint. So we could have also ended up using, okay, so in terms of their instructions, the draw the letter, instead of using choice, so that's one option. Your other option is you could do letters dot pop r dot randint, and then you could go anywhere from 0, comma, and then we could go the length of letters, right? So you could pop that in there where you're going to end up getting anywhere within the length of the letters list to that index. Now, in terms of this, let's take a look at this though real quick. I'm going to go into terminal here. I'm going to bring up Python. What did I just do? I think I just brought up the chat. No, we don't want to do that. Let's get out of here. Let's exit out of this. Let's try that out again. Terminal, new terminal. So let's go into Python in here. So I'm going to go Python 3, and then I'm just doing this as a test here, right, guys? So let's have a list of words. Hi, hello, and hey. Now, in terms of the length of this, so let's print length of words. So we get 3. So if I actually use that as our index, it's not going to include up to that. So 0, 1, 2. Okay, perfect. Yeah, so our code that we have written here is perfect. What I was doing there is I was just checking to make sure that this number would not give us an index out of range whenever we go to pop that off. Because, right, if we go one letter further than the last index in our letters list, it's going to give us that index out of range error that we had in 1, 2, 2. So we can pop that off, right? And then what you can do is you can establish this to be letter, right? And so this is just the second option. What I'm going to do is I'm going to actually roll with option 1. then this is the option textbook has. So it's good to know that how to do that, what they're saying. But I just found it to be more efficient to do the other way. So let's go ahead and let's look at the rest of this in combination with randint to retrieve random letters from the list as needed. Make sure to comb through your code and update anything necessary to draw the random letter instead of just the letter A. Perfect. So we ended up we imported the random module. I imported as R, so just keep that in mind. It's going to be r.randint for us. Record your plan for resetting the apple after its fall. So use descriptive variable names. Discuss your plan with a classmate, and then have them initial your notebook indicating that they have given you suggestions or recommended improvements for your program. Show the initial plan to your teacher. So, guys, in terms of this, let's kind of talk through this, right? Maybe even pause this, come up with your plan, and then we'll kind of check in with each other. We'll connect, all right? So, in terms of this, after this apple falls, what currently is not happening is, so J falls, right? But we don't have the next apple show up. The other issue is that our game is no fun because this first apple keeps showing up at those specific spots, right? Now, that first apple should show up at a random location. Once we click that letter on the keyboard that corresponds with that, right? For right now, we're not going to have that part set up. We're just using A just to go through and make sure the functionality works of this, right? Of getting a new apple that shows up at a random spot with a random letter. But what we want is at the very beginning, the first apple, go to a random spot, right? Random coordinate. Then we want to draw also that letter that's on there. If we press A, then we want that apple to drop. Now what's got to happen? The apple's got to hide, the drawer's got to clear, and then what we've got to do is we got to get a new coordinate, right, for this apple to be drawn at. Now that is the iteration that's occurring here. And so what we can do is we can get that iteration to occur by these functions that we call, okay? So at the end of drop apple, what we want to do is we want to draw the apple again. So I'm going to call draw apple. Now within the draw apple function, you will see that it's going to draw the letter for us automatically. So let's run this code and let's see what happens. We got Q. I'm going to press A. Currently we just have it set up where I'm pressing A on the keyboard. That's going to drop. Now as you can see, boom, we got the new turtle that shows up. It's T, right? However, what's the issue that we're running into? The position is not being updated, right? It's showing up at that same spot. So what we've got to do here is in terms of drawing this apple, we want to end up using our rand module. So we're going to go randomint. Now, in terms of these random integers, what I'm going to end up doing, let's look at our file explorer. Let's take a look at this background image. Let's see if we can get the info. Where do we see info? Reveal in Finder. We could do that. I'm going to reveal it in File Explorer is what it's going to be for you all. Now, do you guys see the dimensions of this? 607 by 406. As you can tell, this image wider than it is in terms of height. So 607. Now, 607, we take that divided by 2. That's going to be 303.5, right? So what I'm going to do, I'm going to play it safe. I'm going to go negative 290, 280 even, negative 280 to positive 280 for our x. So negative 280 to positive 280 for the x. Now let's go back to that little rascal. Where is this at? Background. Let's go to reveal in File Explorer or Finder for us. It's 406. Now what did we say in terms of that? I mean, that's 203 right now. What did I set as my ground position? Negative 160. So what I'm going to do is I'm going to actually use that value. I'm not going to use the ground value though, so that we don't get confused. I'm going to go negative 130 comma to 160. Okay, now that's going to get us random x and y coordinates. Now in terms of this active apple, before I show that turtle, what I want to do is I want to ensure that we have gone to those coordinates with our active apple. So the active apple is currently hidden, right? We're going to end up saying go to, and then we're going to tell it to go to the random x and y coordinates. Okay? Now, let's test this code out and let's see if it works. So we got S. Ooh, guys, that's not good. Something. It's actually still drawing on there. I believe it's Rider. You see how that's a white line? Rider, or the drawer, that one was the turtle that was white. However, do we have this working correctly? Yeah. One other thing is we want this to kind of happen pretty fast, right? Pretty instantly. And so what we can do is we can use that tracer method that we were talking about. So what I've got to do is I've got to set this up. In terms of drawing the apple, We got wn.update. I want there to be no delay in this. So I'm going to do wn.tracer, and then we want to set that equal to, so if we go turns animation on or off. So if we want to turn the animation off, that's going to make things faster, right? So we could do that. Now, whenever we get to our function where we are wanting to drop the apple though, we do want to set the tracer equal to true, okay? Now, what we also want to end up doing in here is I think we also want to end up going wn.update. Now, as to where that's going to need to be updated at, it might actually be after we set that to true. So let's see here. Let's go ahead. Let's run this. So we got A. Nice. Instantly, right? It's showing up there. Now, we still have that where that line showing up for our drawer. So let's go in here. So not draw apple, but draw the letter. I want to do drawer dot pin up. Now, why did that end up occurring? Didn't we have it, guys, where drawer was pin up from initially the get-go? No, we didn't. We just hid the turtle. So if I do drawer dot pin up, we can do that there. That way, then we don't have to end up running that every time. Control L, right? It's going to select that whole line. So now let's run this. Q. Nice. N. J. Nice. Now, is this detecting the actual letters, though? No, it's not. Nor. So, but we're going through this entire alphabet, right? And what we're going to end up seeing after this, now if I end up clicking this pretty fast, it's going to help us cycle through that, but as you can see, it's going to just kind of start to bug out. Do you guys see how this is occurring where we still have apples falling, even if we're out of the alphabet? So we're going to have to take that into consideration too, but that's pretty good. If I go back to the terminal, let's see, can I bring up my old terminal? Nice. So we run into that issue at the very end. Let's roll up here. Was this, maybe this was, okay, nice. As you can see, as we continue, our list gets smaller and smaller for the alphabet. Okay, so that's good. Okay, so now let's go ahead, let's take a look at this. Now that your apple resets, it is time to add code to check and see if the letter the user typed is actually the letter on or associated with the apple. So to do this, you may need to modify existing functions, create new functions, rename existing functions, and add new key listeners and or global or local variables. Guys, this is the part in this activity where most students are going to crash out right now, because if you do not use Python to automate these steps, your life is going to be miserable. And some of you all, you might even be thinking, I'm just going to do this manually, right? What I'm going to show you is a way that we can make this a whole lot faster for step 16. Okay, so just going to kind of pause for right now. Okay, so now that your apple resets, it is time to add code to check and see if the letter the user typed is actually the letter on or associated with the apple. To do this, we may need to modify those existing functions, create new functions, rename existing functions, add new key listeners, and or global or local variables. So what we want to think about is your plan for checking the value of the user key presses versus the letter of the apple. Okay, come up with your plan. Think about that right now. What then you can do, pause this. Once you've got your plan, come back. All right. Okay, so in terms of this plan here for the randomness, what we're going to actually have to do is we're going to have to create a lot of functions. As you can see here, there's going to be a wn.onKeyPress. We're going to literally create a wn.onKeyPress. That's going to be for each letter of the alphabet. Okay. Now, additionally, instead of calling drop apple, what we're going to do instead, if it's just a current letter, right? What we're going to do is we're going to set that as being the active letter. Now, later on, you're going to end up finding that we have to set this up where there's going to be multiple turtles at once, right? In that case, we're going to have a list of the active letters. And what we're going to end up doing here, instead of calling the drop apple, we've got to check and we've got to see if that letter that was pressed is currently in our active apples or our active letters list, right? If that's the case, then we're going to drop the apple. If that's not the case, where that letter we press is not in our active letters list, then we're not going to drop that apple, okay? There's going to be lots and lots of repeated work here that we're going to end up streamlining using Python, okay? So let's go ahead, let's move on to this next part. They kind of talk about reviewing lists here. So in the Apple Avalanche game, the program will need to maintain lists of letters and turtles so that it will know which letters the user has typed and be able to accurately drop the right apples More important, if you choose to link apples to letters earlier from the tree. In this portion of the activity, you will review lists, specifically lists of turtles, so that you will be able to finish the apple avalanche typing game by including multiple apples on the tree. Okay, so they have us modifying our code below by adding a fourth turtle to the turtle list. And so as you can see here, we have the turtle list. Now what I'm seeing here, guys, is there is a whole lot of just the same code that's repeated. They could have ended up just using iteration, right? A for loop, for instance, for turtle in range 4, and then they could have done all of this. They could have also ended up getting the different colors mentioned in there too by using but anyways, what you can see here is they have a turtle list. They're going to append these turtles to that turtle list after it's created. We're going to set the color, pin color is red. If you append that to your temp turtles list, then what we can do is we can iterate through those turtles, right? Have them do certain actions. So this is kind of like the traversing turtles. What they want you to do here is add in a fifth turtle. So turtle underscore list. We're going to end up appending. So adding in the fourth turtle here, we're going to take this. Do they end up telling us that it needs to be any particular color, or do we get to... Okay, so we get to add its color of our choice. Let's go with, let's see if gray will work. I don't know if they're going to be one the British spelling on there or not. But what we can do is we can append that. And then now let's have, what do they want us to do? Turtle list. Head in the opposite direction from the turtle at index 0. So turtle 0 is right there. We're going to go turtle underscore list. We're going to reference that third index. That's the fourth element. Set heading on that bad boy. That's going to be 0. So 0 is this way. If you guys are thinking about this. 180 degrees is opposite, right? So we're going to set a heading to be 180. 180. And then now we're going to end up having the turtle list. Now I know I could have just copied and pasted that previous line. Probably should have done that. We're going to have it go forward 500 pixels. All right, ready? Let's run this code. Now, as you can see, 1, 2, 3, 4. Boom! That one's going the other way. We kind of created the peace symbol there. All right, let's move forward. So record and explain the index error along with the other errors that you have encountered so far in this course. So in terms of this, guys, if we ended up not creating this temp turtle and adding that to the list, if we end up doing this and we run this, there's not a fourth element in there, right? So what's going to happen, it's list index out of range. That index doesn't exist. It's out of the range, right? In that case, it's 0, 1, and 2. It's only after we append that temporary turtle, the last one, that we have the 4 instances of that or the 4 elements in our list, which is the third index, okay? So that's kind of what they want you to take note of. So in the Apple Avalanche game, you will need to iterate over a list of turtles, apples, right, and or letters in order to respond appropriately to key presses. So in the code below, a for loop has been used to iterate over each turtle in the turtle list and make them retrace their path to an extent. And so now it's got this right here, right, where we can end up doing that for active turtle in the turtle list. What we want to do is we want to set the heading to be the active turtles heading, and then we're going to add on 180 degrees, and then we're going to go forward 250. So if you look at this, you can end up seeing what happens there, right? So that's basically at the end there. So they're all going to go back that way that they came. Okay, so when working with lists, it can be helpful to find out if a given list contains an element that you're looking for. The in keyword, so if to in number list, that's going to tell you if this element is in that list, right? Now, of course, in here there is 2, so it's going to end up doing this, right? So we're going to end up using the in keyword for our Apple Avalanche program. So we're going to be needing to be able to provide the user with a new letter to type, a letter that they have not already typed, right? And then we're going to check if that letter is in the list of the current letters that are on there, okay? So to practice this, they have us modifying this code below to generate 4 random numbers between 1 and 4 inclusive to add to the list. So 1 and 4 inclusive, 1, 2, 3, and 4. We're going to add that to the list. So let's hear. Let's definitely just switch that. Let me reread this real quick. Okay, make the turtle write the number 4, otherwise then have it write no 4. Okay, so it's just in this case, if 4 is what we're doing, we're switching this. Then we're going to put 4 is in the list. If not, then it's just an else statement, right? Then we're going to print, or we could have temp turtle, right? Let's just do this. We're going to steal all this. We're just going to adjust this. Temp turtle is going to write. Now, if it's not in the list, what do we want to put down? Otherwise, have no 4. No 4. Nada. So now we can run this. So if 4 is in that list, it's going to end up writing that. What is this saying? List index out of range. Crockies. Yeah, why do they have 4 there? We should have 3. So we just print out 3. Now 4 is in the list. Perfect. Let's take it out. Let's put 5. And it doesn't matter if I put 4 like earlier on in the list, it's still going to detect it. Now what do we end up running in here? Temp turtle is not defined. Oh, it's because we didn't create it there. So then we want to take this. Oopsies. And what could we do instead here? Instead of having it created just there, paste it right here, right? Then we can end up referencing it for each of these, because both of these do need the temp turtle to be created. So there you go. So you have it. So we're going to be using that in keyword, and it's going to be pretty helpful. Okay, so far you've learned to add images and key press listeners to a program using the turtle library. You have practiced your use of the rand_int function and manipulation of lists. You're at a point where you have the necessary tools to complete the Apple Avalanche program. So using your knowledge of lists, plan the rest of the Apple Avalanche code. Your code should include the following features. So the tree holds up to 5 apples, okay? Each apple is going to contain a different letter. That's what we're going to end up doing. And whenever the user types a letter, only the apple containing the corresponding letter is going to drop from the tree. If you choose to display the letters at the top of the screen rather than on the apples, it doesn't matter here which apple drops, okay? We're doing this the hard way, so we're going to go ahead and we're going to go through, all right? So now you can record your plan, pause, write out your plan, right? Once you've got your plan, check back in with us. We're going to go through it. So they have add commented function headers to your existing code to organize the space in your file. Use the function headers found in the code provided in this activity as examples. So we're going to end up using the little code that they have. Now, when you have added all the function headers and comments that you believe you will need,